In this presentation, we are going to look at mixed probability distribution. So we have a random variable x and it has a mixed probability distribution, which is to say a combination of a discrete component and a continuous component. So over one sort of range of values, here it's just one particular value, x equals 0, the probability is a, discrete probability, but over the rest of the values, it is between 0 and 1 essentially, it is continuous. Okay, so it's discrete here and continuous here. Okay, so essentially we join them into one overall probability distribution. If the mean of x is a, find a and b, and hence the standard deviation of x. Now, here this is just happens to have the same value as the probability value above. Okay, so just make life easy for ourselves, really. X is a random variable, so the total probability on area under the curve, so to speak, is 1. Okay, so the total probability, so this is the discrete part, this is the probability here, okay, and it's really just the probability, just as we're told in the first part of the question. So that's for the discrete component. For the continuous component, that is the area under the curve is the probability. Okay, so altogether that adds up to 1. Okay, the total area under the curve. Okay, so essentially what we have here is an integral, and hopefully you should be fairly okay with these sort of integrals. What we're going to do is just factor out b and integrate from 0 to 1 x squared and x cubed, and we get x cubed over 3 minus x to the power of 4 over 4. Definite integral from 0 to 1. You should work that out to be 1/3 minus 1/4, and we pre-multiply that by b, so just don't forget about that b, and also a as well. A plus b times 1/12 equals 1. Okay, so that helps us get started. Okay, so the total area under the curve for the continuous part plus is a probability, and the plus the probability from the discrete component of the distribution as well. Okay, so that's one important equation. Essentially what we're doing is setting up a set of simultaneous equations. Now what we're also told is the expected value of x equal to a. Okay, so again we're going to break it up into two parts, our discrete part and our continuous part. Now, so just if you recall, for a discrete distribution, the expected value of x is the sum of x times p of x. Okay, and that's what we have here. That actually just cancels out to 0. A times 0, here x equals 0, the probability of x is a, so but it just all cancels out to 0, so we can just disregard that. For continuous distributions, okay, it is the integral of x times f of x dx, okay, from the upper and lower limits. So you just evaluate the limits from the upper and lower limit of your range of values. Okay, so again, so it's really the continuous part of the distribution that we're particularly interested in here. Okay, so we have, essentially it's very similar to what we've done before actually. It's just we have x cubed times 1 minus x, or b times x cubed times 1 minus x dx. So just factor out the b, okay, and we have x cubed minus x to the power of 4. So break it up into two parts and we get the integral of both, the definite integral from 0 to 1 of both. So the integral of x cubed with respect to x from 0 to 1, that's x to the power of 4 over 4. Likewise, x to the power of 5 over 5 for x to the power of 4. Okay, evaluate that from our definite integrals, our limits, 0 and 1. Just like the last time, we end up with 1/4 minus 1/5, which is 1/20th. And again, we have that multiplied by b. We taken b, factorize b out, so don't forget about b. So we have b plus 1 over 20 equals a. Okay, so we have two equations and two unknowns. Okay, so we have this expression here, okay, and this expression over here. So essentially what we can do is combine them into one single expression. Like what I've done there is just actually I can re-express this as b equals 20a. Okay, and just above we had a plus b over 12 equal to 1. Okay, so what I'm doing is combining both of those into this expression here. A plus 20a over 12 is equal to 1. Little bit of number crunch in there. You should get a is equal to 12 over 32, which is 3/5, which is equal to 0.375. And in that case, that would make b equal 20a, which is b times 20 times 0.375, which is 7.5. So those are the two numbers we're looking for, 0.375 and 7.5. Now, what we have to do here is compute the expected, or the variance, and then the standard deviation. Now, we were told this earlier on. This is the expected value of x. That's a squared. Okay, so we don't really need to worry about that. So what we have to do is look at this part here. Okay, so we need the expected value of x to be squared. Okay, and this is actually following along, again, just to clarify for the discrete part. Okay, so what we're working on here on the basis is that this is the expected value of x squared times p of x. Okay, I should have brackets on that. Okay, so this is just like the discrete random variables calculating the variance. Okay, so that does that for the discrete component. Then we look at the continuous component as well, which is the integral of x squared f of x dx, okay, which is that part there, okay, and we just take b out of it just to make life easy on ourselves, make it easier to read. So the discrete part is the expected value is 3 over 8 times 0, which just goes to 0. So like again in this instance, what we can do is just concentrate on the continuous component there. And again, this is again a definite integral. So b here is 15 over 2, 7.5 if you prefer. Okay, so we're integrating x to the power of 4 minus x to the power of 5. When we integrate that, we get x to the power of 5 over 5 minus x to the power of 6 over 6. And our limits of integration are once again 1 and 0. So this just sort of cancels out or simplifies down to 5 over 12 times 1 over 5 minus 1 over 6, which is 1 over 30. So we end up with 15 over 60, which is 1/4. Okay? So that's the expected value of x squared. Okay? And we know that the expected value of x is a, which is actually, I sort of forgot to mention that is 3 over 8. I just sort of stated that it was a squared. I should have gone a little bit further and sort of say it's 3 over 8. Just sort of forgot that. Anyway, we have 1/4 minus 3 over 8 to be squared. So that's 16 over 14 minus 16 over 64 minus 9 over 64. That gives us 7 over 64. Okay, so that's it. Sorry, I'm just scrolling up and down there. So that's our answer to that part there, the standard deviation. Okay. So I think the thing about this question really is just knowing how to that you can break it up into two parts, okay, over one range of values, okay, and just work on each part independently and just add them together to get an overall whole, okay. So that's the discrete part, and this is the continuous part, and altogether they make one overall probability distribution, which will have a total probability of 1. So that's really just what to keep in mind. Just break it up into two parts and do what you should be able to do in both for both sub-components. Just sort of piece it together and then build it all up into one piece. Okay, we'll leave it there.